Hey there guys, and welcome back. So this is the first time getting to use the whiteboard, so we'll see how well this actually works. But the point of today, whoops, and I killed that, there we go. Trying to get focus over here. The point of today is to make what I'm going to call a horizontal disc grinder. So in case you didn't read the description, basically I have a chisel to grind, and instead of using any of the tools that I have at my disposal that require absolutely no effort, I decided to make this thing, or at least attempt to make a DIY version of this thing, because it's an interesting idea. So basically what we're looking at for the design here is we'll toss in some 2020s to build a cage, and so simple cage there. This is kind of funny using back to, I have this Wacom tablet. I've had it for a while. If you did not listen to the talk stream the other day, I talked about pulling this out and trying it out. So things are going to be sloppier than normal for the time being, just because I want to at least give it a shot. But we'll have a 6-inch disc up here. You won't actually be able to see it like this. It, technically speaking, you know, from this angle, you'd only be able to see that, but it is a round disc. And yeah, I'm gonna try it one more time. There we go. The thing is I've done a little bit of research right before the stream, and I think what we're gonna actually need to do, because I want to power this with the Dremel, is I think we're gonna have to put a belt reduction in here. The tricky part is that I'm gonna have to build my own GT2 pulley at a 10-to-1. So on the Dremel side, I'll use the normal 5mm. Well, I've got a 5mm bore pulley. I've got several of them sitting around, so I'll use that on the Dremel side. And then in that case, if I need a 1-to-10 here, because basically my research. Actually, let me hop over to. Hopefully this is queued up correctly, and you got the blue screen of death. Very good. There we go. All right, cool. So as you can see here, I did a little bit of research, and this one that I'm kind of basing the idea on is a 580 RPM. My Dremel bottoms out at 5,000. So that would be a 1-to-10 ratio, okay? And that means that if the outside diameter of this guy is, let me double check really quick because I didn't double check, but let's see. So OD on this guy is about 12mm. So that'd be 120mm OD. So at that point, it's probably going to be a 2-stage reduction, or 2-stage gear up, I guess would be more accurate. 1-to-5, 1-to-5. Let's see, 5 times 12 is 60, so 60 is about 2 inches. So that's still a pretty big pulley, but it's a lot better than the 120, which would be close to 5, like 4.5, something like that inch. You know what? Maybe we try it out anyway. And I only say that because I bought the multi-pack of hoops, as you may remember. So I have a whole bunch of, and I'm gonna have to refocus this window. There we go. So I've got, you know, all of these sizes in that multi-pack. So I have nothing to use them for. It may be interesting to do the 4-inch OD pulley that will be 3D printed in order to do it in one reduction. Otherwise, the other interesting idea here is how exactly to get this set up. I'm thinking what I want to do, and what I've already imported into the Fusion file that I started up, is to use the flex shaft to save space. So we'll use the flex shaft. I'm thinking just mount it to an extrusion, one of the vertical extrusions. That way it's in the same orientation as this shaft here, and then run that like that. That's my idea. Frankly, I'm not sure how much of this is going to work. It was just a really interesting idea I decided that I wanted to try out. So, what happens at this point. Otherwise, I did do a little bit more research just to double check. And we'll hop over to my spreadsheet. So as you can see on the spreadsheet, this is our sample RPMs. It's just 500 rounded. Again, bottoms out at 5,000. If we do 1 to 10, that's 500. And then I've got these sizes right here. Somebody can double check my math here, but I think I got this right. So assuming that we have a 6-inch disc and run these bearings. Oh, actually, you know what? I didn't really demonstrate that on the whiteboard. So let's take a quick look at that. So point being is that with this disc, when we put the chisel down over here, or whatever we're sharpening, it doesn't really matter. But when it comes down over here, right, it's going to want to put pressure there. So I'm thinking of doing this the same way we did the turntable. Well, not necessarily the same way because it is a little different, but basically just making spokes. And one of those things, we can put however many of these we want. You know, it could be 6, it could be 3. I'm not really set on that, but tossing bearings on them and then having the plate run on the bearings. And technically speaking, I should draw this like this because the shaft has to come through right here. So these bearings would be supporting the edges right here, here, and then wherever else, you know. That way we're pushing down and have support underneath we're pushing down. And the point being is that if this is a 6, whoops, that is not going to work. If this is going to be a 6-inch disc, then we set them in, let's say, 1 inch. And this is 5 right here. So that's the idea. So that's where the 5 inches come from on this spreadsheet. So again, assuming I pulled this off of PGN's website, that's the bearings I have. Now the interesting thing is that they actually do not have the 623 ZZs on their website anymore, but my pack clearly says PGN bearings. So I don't know what happened with that. But they have the 624s, which is the, you know, one step up obviously. The 3 and the 4 are the IDs. And looking at this, it seems like as we get smaller, the RPMs go up. That may not necessarily continue from 4 to 3, but I figured we're safe keeping with the 4,000 here. And then one of those things, bearing diameter, bearing circumference. So this is how much distance, you know, is for one rotation on the bearing. This bearing ratio is the bearing circumference divided by, or bearing ring, sorry, the bearing ring circumference. So this is the 5 inches into millimeter circumference. So this is the circle, how far the circle travels in one rotation. And again, we have 500 rotations per minute. So that one rotation ends up with 12.7 rotations, for example, of our 623. And then if it's doing 12.7 more rotations than our 500, that gets us to the 6,000. And then this is just a sanity check here too. Sanity check that we are in fact underneath the max RPMs according to PGN's website. So again, assuming that I understood all that correctly and I didn't screw the math up anywhere, that should all be kosher. We'll hop back over here really quick because I still have the things up. One thing that it does not say here, and I did not go looking for a more specific stat sheet, is what is it? It's not axial load, right? Or is it axial load? Basically, no, it's dynamic load. Yeah, it's dynamic load. So that's 295 pounds. One of those things. I imagined it was significantly heavier. We're not going to put 295 pounds worth of weight on top of this bearing, right? We're just pressing a chisel down in theory, or other tools. So that should also be safe. Again, it's not something I really looked at because I didn't figure it was going to be a problem. One last thing I would like to say, because I kind of glossed over it in the beginning. So I said I have all these other tools to sharpen it with, and for example, I have my sanding jig that we made. That was, I don't know, that was a while ago. I can't remember how long ago that was. That would be useful. I could do that, so that I could do that by hand. Perfectly reasonable. one of these things, the reason I'm not doing that is frankly because I happened to be looking around at sharpening chisels and saw this thing. And I was like, oh, that's a cool idea. The other thing is I do have access to bench grinders, which would be the other easy thing. And I've seen people sharpen chisels on those. The interesting thing is that when I was looking at doing wood turning with lathe, right? The lathe guys recommend not using the bench grinders on their chisels because it scallops the chisel. So one of these things, if I've got a round circle, whoops, let me Control Z that. Let's come, no, let go. So if I've got a round circle right here, right? And I press the flat edge of my chisel into here, you can see how this little radius right here, let me see if I can't zoom in. There we go. So you can see how I get a radius on the edge here. Now that may not necessarily matter because the only thing that really matters is this point right here, but it does hollow out the edge a little bit, in which case I assume that it wouldn't hold the edge as well as opposed to a normally with the chisel you end up with, if you're sharpening it flat, right? You end up with a flat edge like that, in which case there's a lot more meat right there, so it's less likely to curve down this way, right? It's not less likely as you're driving the force into the workpiece. Obviously there's force pushing back this way, and therefore I would expect this lip to have the most amount of force coming down this direction, right? Potentially also this direction, in the opposite direction. Yeah, you figure if the curlings want to curl up like this, then in theory the blade also wants to curl up like that. Point being is that in either of those directions you have significantly less meat if it's scalloped like this because you're using a grinder. So that's my rationale there. So aside from it, just again, if I wanted to get this done, if I honestly just wanted to get this done and over with, I could just use a bench grinder. And like I said, most people who use hand chisels on general woodworking, as far as I can tell, just use the bench grinder. Which, you know, cool, good for them. It's just I think it'd be interesting to have this other thing. Now, this is going to frankly get outmoded in the future because I do plan on picking up at some point, or not picking up even. I actually wanted to try to build a belt sander. So that is one of the projects I want to do on the channel. But for the time being, this is an interesting idea. The other thing is, in theory, it doesn't matter what orientation this is because this is going to be a cube. I could set it on its side and then I have a vertical belt disc sander, right? So that's the other nice idea behind it, is that I could also use it for normal disc sanding stuff. In theory, assuming it works. So let's pop Fusion open and start doing some design stuff. Fusion, Fusion, Fusion. Where's my Fusion button? There it is. All right. So this is the little mock-up of the Dremel flex shaft end. Okay. Obviously do not have the cord on there. Shouldn't necessarily matter because we don't necessarily need to grip the whole thing necessarily. So necessarily speaking, we will continue with everything else. Let's see. The interesting question is where to start, because we have a few different moving parts here. So I think it's probably just easiest to start with the disc. Now the discs, I had not mentioned this, but I'm thinking of just 3D printing these discs and gluing down, maybe getting some spray heat adhesive and just using normal sanding paper and just spraying down onto the sanding discs. How they attach to the central column is another interesting idea that I didn't really go into too much. I figured maybe just use a hex bolt and then a collar underneath the bearing, center bearing. We'll see where we end up. I'm gonna go ahead and start designing this and see what it looks like. So yeah, I think disc is the good correct part to start out with. So this is the disc, and I guess we'll just use the origin for right now. I don't have any reason not to start on the origin. I don't think. We'll move the Dremel shaft thing later once we have a better idea of where everything is positioned. So this is going to be a 6-inch disc, 6-inch. And any other considerations here? Just the center hole. Center hole is interesting because I believe I'll be using a 608, right? So this is going to be an 8mm shaft right here. And then, let's see. Yeah, the question really is what I do with that 8mm shaft. Whether or not I weld a nut onto the top of it or something like that, that's an option. Or we could attempt, so it's 500 RPMs. I'm kind of interested to see whether or not a 3D print on 3D print would hold up on underneath these torques. So I think, let's see, what kind of a hex looks alright on here? That's 8mm. Actually, you know what? I have 8mm nuts. That's right. I did pick those up. 1 second. And did I model them actually? So one thing that I don't think I've gone into, I've mentioned, is during the break, when I took the winter break, I went ahead and put together, where'd it go? Oh, I didn't pin it. I started putting together this because I always go and just manually enter the sizes, right? So I'm starting to keep a library of nuts and bolts that I use to make my life easier instead of constantly. So it's like 5.45, right? I know that size for M3s. Let's see. What other sizes do I know? Honestly, that's like the only one I know because that's the one I use 99% of the time. I know that when I did the the twos, I looked at it and I went, oh, you know what? I do know that size. You know, like it struck me as being something that I've used before, you know? Like, oh, yeah, of course. But at the same time, not having to re-enter all this stuff all the time. So this is 12.8 here. Is useful. And I'm sorry, I forgot. So what I did, if we hop in here really quick, is I made them base features, was the more important part. So the two things. One, for the record, unfortunately, base features do not actually use parameters. You can set it initially with parameters, but you cannot update the parameters and have it change on the base feature. So that is something to understood. Not with cross flats and 12.8. So I can use this to set it up, and when I import this model into the Dremel powered horizontal disc grinder, we'll be able to reference that, you know, just grab that reference. But unfortunately, I can't just grab, for example, the M3 nut, hit modify, and then save a copy. That's not going to work. And it looks like I just did width and thickness is actually how I label it, so I didn't even include the size. So just width and thickness. Oh, I've got this set of magnets that I've been too lazy to put back. Actually, I take that back. It's not so much that I'm too lazy to put back. I was playing with them, and evidently they're cheap. So they started chipping and flaking, and I didn't particularly want to put them back because they look like crap. I don't know, you know, one of those things at this point I probably should have just thrown them out. But for whatever reason, you know, I think I'll use them even though they look like crap, but if I think I'll use them even though they're tripped and flaking and stuff, then they should just go back in the box, and I have no idea why I've yet to do that. So, great base feature. There's my hex gun. With 8. Nut design. Constrain it. Thickness. There we go. Toss the threads in here. Threads. Should default to M8s. Yep. And we only need to model that, or we only need to have that visually, not modeled, and it's just a nut, so I don't think I need to do anything else. So this is a curious thing. Did I do this over here on this nut? No, I didn't. So one of these things, if we look at, I mean, it really could be any of these, but let's look at the pan head, right? So I actually tried to get this looking like it looks like. So for example, I rounded the insides of this. I tried to get this radius pretty darn close to what it is in real life. The hex head stuff, they have a slight concave on the corners, and I tried replicating that, but it's a little bit difficult. So I guess that's why I didn't do it. I was curious whether or not I went back and finally did, but evidently not. The interesting thing is that this feels a lot smaller. Huh, I mean, it's one of those things, calipers don't lie, so. Okay. And let's get, so it doesn't actually have zinc in it. We don't actually have zinc coating as a thing, so I think I was just using chrome. I think I was just using chrome as the appearance. And we'll go ahead and save that. Save. Oh, shoot me. I am in the wrong file. Don't save. Oh, in that case, what did I use on that? Stainless steel? Okay, I want stainless steel, evidently. Satin. There we go. Alright, cool. That was only, what, 7 minutes that we did not need. M8 nut. Oh, wait, sorry. Finish base feature. There we go. Save. M8 nut. Come back over here. Finish. Step back. Up here. Insert. Proceed. Okay. Disappear. Parameters. M8 nut. There we go. And should be fine. Let's just drag this back one. And this is why I was doing base features for these, so you see how this is significantly less obtrusive than when I insert it normally. Assuming it's not linked. So this one's linked, so it's, you know, nice and clean. But when you cross-reference them, gets a bit messy, which I was trying to avoid. Point being. And this is M8. M8 nut width. And let us extrude. So I think I'm going to extrude this up. Should I extrude this up? Yeah, I think I will. I think it makes my life easier. So let's see. What's a good thickness? I guess a good thickness. Alright, so here's an idea. So let me do this. Let's back up a hair. Look at this. We have two questions here. One is whether or not this actually needs to be solid or how solid it needs to be. The other thing is, let's make it nice and thick there. The other thing is whether or not it needs force going down on it. So here's the idea. If we make this thickness, I make thickness, okay, and then from object, whoops, not that guy, that face please, thank you. Let's make it a little thick to start out with, so we'll make it 5 millimeters thick, which is nearly a 1/4 inch, a little under a 1/4 inch. This should be a join. I forgot to also select the ring there. That is why. There we go. Oh, shoot. And it misunderstood what I wanted. There we go, much better. And actually, that should have been... Wow. Being all sorts of sloppy tonight. There we go. I did start a bit late tonight. So one of these things, this design, I've been thinking about the channel, and the reason I've been slightly less... So there's two reasons, right, why I haven't been streaming as much. The first is working on and trying to get stuff running outside of streams. So for example, I got those videos, and I've got a couple other projects I'm working on. Not capture. And starting last night, I went ahead and started up other socials to try that out. So we'll see what happens with that. I set up an Instagram and I posted a few pictures of stuff I'm working on last night and then again today. So that took up some of my time. And, whoops, wrong button. I also did some other reaching out, and we'll see what happens with that. So one of these things, I'm trying to at least put a little bit more effort in. I am going into my second year of doing this. I wasn't too concerned about it in the first place, in the first year, because one of those things, there was a lot of experimentation going on this first year. So I wasn't too concerned about like trying to be a super big, massive channel or anything like that, trying to get the channel bigger, just doing it for fun. But I figured one of these things, we've been doing this for a full year now, so may as well put a little bit more effort in. Now, if that does mean that we do less streams, then one of these things, we'll see what happens, see where we end up. If doing less streams and doing more of the other stuff helps the channel and gives me more incentive to invest more in the channel, then that seems like a good trade-off to me. But one of those things, only time will tell. I'm not going to make any predictions or say that that's definitely how the channel's going to, the direction the channel's going to go. Enter shaft. It's just a wait and see at this point. So. We'll use that sketch because that has my 8mm rod in here. And I do have 8mm. Actually, no, that's right. We're designing our own pulley. I was going to say I have 8mm pulleys, but that doesn't necessarily matter because we are... I thought I had extrusion on here because we're making our own. From object. So we're going to want... again, the distance here is a little bit up in the air. This is actually not set yet. We can just set it to an arbitrary amount for the moment and then come back and edit it. I don't think it's going to break anything. In the meantime, I don't think it's going to cause any problems. And let's just say 4 inches. Let's say we extend 4 inches down that way. Maybe entirely too much. It's just a matter... Actually, let's take a look at the Dremel. Dremel is... turn that off. Turn that off. Dremel is 108mm, which is about 4 inches. So 4¼ inches. So that is just the body, and then we add another, so we'll say 4½ inches probably to the output of the Dremel. So this 4 inches may very well be adequate, although depending on where we put the Dremel, we may be able to move that up. We may be able to shorten this 8mm shaft up. So we are going to go ahead and rename shaft body and toss some threads on this guy. And instead of doing the full thread like we normally do, we'll just do a partial thread because we don't actually need it. That's M8, that is correct. Not full length. So it's a shame it doesn't have 2 object here. So I'm going to say 5 plus thickness, and that's all we really need, right? And we're not printing this, so we don't actually need to model it. It can just be an appearance. Let us come back over to disk really quick and get some references in here. Okay, this is top of disk. We're going to need these to set the wheels up. Whoops. Turn you off. 0. Okay. I guess we don't necessarily need this. We could just... Yeah, we'll probably just end up, I take it back, just taking an intersect or a projection of the disc, now that I'm thinking about it. But they're here in case we need them. Okay. Thinking about this really quick, if we put a nut on that shaft and it is right-hand threads, is that going the opposite direction? So we're assuming that this is spinning clockwise, right? So we look down on it. Or are we looking up on it? Shoot, which direction are we going? Oh no, it's the same direction? No, it shouldn't be the same direction. I'm just curious because I may want to do, depending on the direction of rotation, in theory this nut, we want the nut as the shaft is rotating to be pulled against the threads down to the bottom of the threads where it hits the solid rod. That way it can't spin any further. That's the idea here. That's what I'm thinking about. So we'll want to take a look at that. Do I got no, I don't have a threaded rod here, but I do have M8 somewhere. No, I take that back. I don't have it. That's right, I don't have M8s. I only have M8 nuts because of the threaded rod, because I keep on using threaded rod. But that is a consideration. And that, again, that's not something we're printing, so we don't necessarily need to worry about that in the model just yet. I'll come back and correct the model once I figure out where exactly, or how exactly that needs to go in order to make sure that it tightens in the direction that the shaft is spinning. So. I think we're ready for the wheels now. New component. Support bearings. Okay. Let's come back over here. These are in downloaded. Downloaded. Where's my 608s? There we go. Inserted. Proceed. Okay, that's fine. And these, because I downloaded them, do not come with metrics. So I know it's 22 on the outside, so let's get that down. 608 OD. Whoops. That is not a new user parameter. 608 OD is 22. 22. Oh, that's right. Cannot start with. We'll do B for bearing. Cannot start with a number. And I guess I may as well add B608 ID as the 8 millimeters. Again, the 8 on the end, in case you do not remember, is the ID, or yes, ID. 6 is, shoot, I always get this wrong. 6 is the bearing type. 6 is, so that would be single row bearings, if I am correct, single row radial bearings. And then the O is the service factor, like the, shoot, what is it? It's how tough the bearing is, basically. I think it's service factor is the correct word. I don't know. I'm repeating this right now because I really should have that memorized at this point for the number of times that I've looked it up. Regardless, let's see, actually. Huh. I'm trying to figure out how I'm going to set this up. How I'm going to extrude this out. I guess how we'll actually extrude it out is do some more planes. So I've made 3 planes so far that we absolutely will not use, and now I'm finally going to make a plane that we can use. Where's the origin at? Origin. And let's see, where's the front? There's the front. We'll take that right there. And I guess we'll do 180 so it's back up front again. Does this make sense to me? I think this makes sense to me. Yeah, I think this makes sense to me. And then pop this back 1 inch. So this is the... Hold on, let me fix this. Bottom of disc nut capture. There we go. Disc front tangent. And this is the disc support tangent plane. Actually, you know what? Since this is specifically for the bearings, let's go ahead and put that in here. Makes sense, makes sense. Okay. Disc support tangent plane. Front. There we go. And I really quick need to fix this because I did not enter the information. There we go. And I think that is good. So let's turn that origin off. Let's hop in here. Click that. Project out. Turn this off. We'll be extruding to that plane is the plan. The other question is whether or not... Actually, you know what? One of these things. I did not have a very concrete plan going into this, but. We're going to get there. We are going to get there. Yeah. Let's do this. Should this be a separate assembly? Question. So, I told you earlier on that we'd have a bearing right here supporting the shaft. We're also probably going to have another one towards the bottom just to give it 2 points to rotate on. And the question is this, are we going to build this into, I think we will build this into the support bearings. That makes sense. So, let's grab one of those guys that we did not use. This is the bottom of the disc nut capture, so we'll use that guy. And project out the shaft. Let's turn some stuff off so that we can see what we're working on. Turn off the center shaft. And we don't need this bearing just yet. Oh no, that's not that bearing. What is that? Oh, that is the Dremel. Somehow that got turned back on. B608OD. Toss this on here. And now we just make our little housing for it. Whoops, no. Only really need a 3mm wall. Don't need to get fancy. And then on the bottom, well, see, that's why I put this over here, because I don't want it associated with the origin point. We'll set this to, it can be any number of things. I'm going to go like 3, I think. So basically, one of these deals where if I need to extract the bearing, right? Actually, you know what? I'm just going to let's close this guy really quick. Downloads. There it is. Let's open this up really quick just to check. So if I'm going to extract the bearing, then I want at least this much clearance right here, which is about 11mm, let's call it. We'll call it 11mm to be safe, plus a little bit, so let's call it 13. So I want at least 13mm to be able to get a punch in there and punch it out. So instead of doing this, I'm just going to call this 13mm. There we go. And that should be good enough. So this is this is the shaft. Right? I mean, shaft. I'm just gonna call it the shaft ride. Bearing capture design. Works. Extrude out. This. I do not have the thickness on this guy. What's the thickness on this guy? Thickness on this guy is 7mm. Parameters. B608. Thickness 7mm. B608 thickness. Do I want to add any offset? You know what? Maybe we add a little bit of an offset up here. Just to give ourselves a little bit of breathing room. 2mm is fine. And then I'll grab that guy again. And we want all this from object. And any old number is fine. 3 is fine. Join. And we can go ahead and take this guy for right now and shove him in there. And I do want this farthest down ring to be lined up. And flipperooski, there we go. Capture position. Add a little bit color. We already used that. Plastic. And let's go brown actually. Alright, cool. Cool. Rod's gonna be 8, so we're gonna have to go below this, right? Actually, this will be interesting. We'll see how this turns out. This central body part may look a little bit weird, but we'll see what happens. So now at this point, I actually think I will use this plane instead of going from the center. And we're going to need, again, that plate because I got rid of the previous sketch. There we go. bodies that do this. 8 B608 OD, and let's fix this to be B608 ID, and we want this to be yeah, this is all going to be that can be solid, that can be tangent to that, and let's keep it on center, centered on that, and it looks like it's already at a right angle. Okay, let's get rid of that and make sure that this is just referencing that, because that's more important. So that's where that's going to end up. As you can see, that looks like it is going to have a weird interaction with this guy right here, which I guess is not that big of a deal. Let's see. So we're just going to extrude a shaft out here where we'll put a lock nut on the, and yeah, so we'll put a lock nut on the back side, and then it will only be threaded as far as it needs to be threaded. Actually, no, that doesn't make any sense. I guess we'll pin it. I guess we'll pin the bearing on the shaft. The shaft, this bearing does not need any housing. So I'm thinking we're actually going to just pin it on both sides, is going to be the plan. In which case this should extend out a little bit more. So let's say like 3 and 3 for 6. I think that makes sense. Okay, that's the plan. Let go of the circle. I don't want the circle. There we go. All right. So this is going to go 6 this way, and then 2-sided. The shaft can come all the way up to that edge, and this is going to be a new component. Support shaft arm, I guess we'll call it. Rename that accordingly. Support shaft arm placement, I guess, is the only thing we can really call it, because it's not really a design. Rename this. Okay. Come down in here, catch a tangent plane. I should get ourselves a proper reference. Tangent plane. Grab the origin. Origin. There we go. We are in the correct orientation for what I want to. Well, actually, it doesn't even matter what. So we'll grab this, project that out. And the plan was to use a 3mm. Let me do this really quick. Turn you back solid. Turn you off. Get you centered. Grab that. And make this a 3mm rod. And this distance here is 3 plus that divided by 2. There we go. Funny how that doesn't quite look. Oh, that is why it's the our first instance of the video of the mystical fusion double line. Centered on there. And that should be good. Actually, let's toss the other one in while we're at it. So this one will go like that. Be there. This is the pin on the opposite side. And in between, we will need... not that one, that one. There we go. That is tangent. That is tangent. There we go, good. And our thickness here is... +3 thickness, and let's just call it +1, just to give ourselves a 1mm breathing room. And to get the sketch constrained, this will be a B608OD, and we can center that. So that places our pins or to retain rather the bearing, all the bearings individually. Turn the body back on, do all, Flipperooski, okay, extract, yeah, I guess I may as well. Two-sided. Let's say 3mm sticking out this side, and this is going to be 8 plus 3. Okay. And undo that because I wanted to actually make new components for the heck of it. 3. 8 plus 3. New component. Okay. Rename. Support shaft arm. Bearing pins. Bearing pins. There we go. And I'll save the rigid assembly for a minute. Actually, no, let's not. Let's not. You know what? Screw it. It's going to be all children. That's fine. And let's copy this. Paste here. Paste new, I think. Should be fine. And I'm just going to drag it out of the way so I can see it. We will reposition it. That on that. Okay, and then slide you. Component. That guy. Translate. And -3, -3. Yeah, I think it's just -6. There we go. And let's drag this down here. Oh, Control Z, capture, and now drag this down here. There we go. So that captures that in that. And now we can start designing the actual connection point here. Now, the interesting thing is how we feel like connecting this, whether or not we want to pin this as well to this plastic body right here. Or whether we'd want to just insert it. Because the bearings are just going to be rolling. Actually, you know what? Maybe we don't want to design it like this. Yeah, we may not want to design it like this. I think it is actually better. So, yeah, the more I think about this, the more I think it's better we not design it like this. Specifically not design it like this. So, how are we going to design it then? Sure, we may... one of these things. Every once in a while, you waste like 10 minutes of your life. Oh, well. Let's see. This is where we started it, right? Yes. All right. Delete everything after this. Delete after. Delete after. Where's my delete after browser arm? Deleted. Deleted. All right, all right, all right. So here's how it's gonna go. Here's how it's gonna go. Actually, we might even delete this at this point. Ah, ha ha ha. Actually. No, that's fine. Never mind. I take it back. So we did not delete the important thing. Come back up here. Delete that. And then this guy. What if I... Let's see. Here. Okay, I wasn't sure whether or not I get away with that one. Obviously, I do not. So, what we'll do is we will paste new, drag you over, one of those things I don't particularly like designing off of an alignment, because Fusion does not remember how alignments work. But this is going to be one of those times where we're going to live with it, because it makes my life easier. Okay, but what if I want the inside of that? There we go. Center on that guy. There we go. So that's on that 5-inch mark. And what I wanted to do is capture position, design like this. This is what I'm thinking. Does this make sense? I think this makes sense. So I'm gonna project that out. Project that out. Actually, let's do this. Project that and that. Make them X's for right now. Turn that guy off, turn that guy off, turn that guy off, 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 off. And we're gonna go ahead and end. I guess we'll just start right here. Actually, we will start in the center. We will start in the center. So I'm gonna create an arm out like this. Is the plan. And do this, and do this, and do this, and do this. Do this, and come back to here. And drag that up, and make this collinear, I think. Actually, it could be collinear all the way up here. The question is how thick we want this arm right here. So if I make this, let's make it pretty thick. Let's make it 5 millimeters. Give ourselves a 0.5 millimeter clearance there. This needs to be in line with the center point. No, I take it back. That needs to be above the center point. So let us hit the X button, grab a rectangle. Well, technically speaking, this should be perpendicular to, or actually parallel to, that is how I really should define it. Grab our center point, make sure that is going through here. Actually, let us grab that and just center on that. Makes sense. This is 8 millimeters. That will be collinear with that. This thickness right here, I don't think, yeah, let's make it 5. Let's make it 5 anyway. And then again, we can just give ourselves like 0.5 here. What's a washer? What is a wash? I don't have any 8 millimeter washers. Should put a washer in there. Is what we should do. Let us, for the time being, this is not going to have any weight on it, so we can make that just 3 millimeters, just a generic 3 millimeters. Then continue on with the same exact thing as this, and drag you up, same as that. And where is this edge? Huh, that wasn't lined up before, right? Why are you stuck? Oh, that's why you're stuck. Okay, because I centered you. That makes sense. For why? Wait, what happened to all my... Oh, my history disappeared. Rip. Alright, there we go. So that's what we're looking at. And the question was, how thick do we want this? Does it matter to us how thick it is? Because this could be all the way up here, right? We could have this all the way up to here if we wanted to. I don't think I'm going to bother. I don't think there's any reason to make it that thick. So we'll just conclude that like that. And make that solid. Bodies. Symmetric. metric roll. And we have an 8mm shaft plus these, so the left right here, because the shaft's going in the center right here, right? So the left right really shouldn't have too much force on them, so I'm thinking about making them 3. Yeah, let's just make it 3 apiece. There we go. So this is the design. It should be actually arm bearing now, because we don't really have a shaft sticking out this side. So instead of shaft, should be support bearing arm placement. And I think we are kosher at this point, so we can move on to tossing the hole in here, rounding up these corners a little bit to make them look good, and then we would be done of this part. Done this part. So outside support bearing arm. I want to project the inside of that, honestly. That way I can get the center on it. Oops. Want to hit the bodies. And we want the center of that. 8mm. And toss our hole in there. Distance to object there. Cut it. Bearing shaft hole. And let's copy that out because we're going to need it in a second. Extrude to object. And this honestly should be able to be press fit in. I don't think we actually need to pin this. We'll see what happens. New component. Actually, I don't need 2 color. I was going to change that to stainless or chrome, but probably not really necessary. I guess I'll save the rigid for a little bit later. Boop, boom. And let's just round these guys over for looks. And I made this 3mm, right? Oh, I guess it's 5mm on top. But we're not going to round it that much. I'm just going to do a 3mm round. Again, it's just for looks. And at this point, where's that bearing? All right, there's that bearing. So, align. It's probably not going to move at all. Oh, no, it does. I take it back. That's actually pretty interesting that it does move because... yeah, that doesn't make terribly much sense, does it? Oh, I see what happened. I see what happened. Somebody had a derp moment here. I centered it on here. That is absolutely not accurate. It should be centered this direction. But we had this. That divided by 2 plus 5. There we go. Finish. And now, when we bring this guy back in, turn the arm off. It is not placed correctly. Let's see. We had 5mm roll on top. 8mm. Huh. What did I goof up on this? Can't goof that one up. This one I can goof up. We grabbed that. So the 8mm, my 8mm bar is, oh, it's only 3 from the top, not 5. Alright. Let's see where we're at now. Look centered. Alright, good. Good. Alright. Now, actually, leave that off for half a second because this guy, and I keep that there for a reason. Let's, actually, let's just grab the whole entire bearing, just to be safe. Revolve. Wrong thing is rolling, so let's reverse that to that whole entire bearing, to that. It's funny because I make that mistake all the time. I always grab it in reverse order. I don't know why I haven't been able to figure that one out. There we go. That rolls now. I'll tell you what's funny. Actually, do I want features or do I want bodies? We're gonna do two. Starting the socials, right? When I started Instagram, started uploading, like, I had a few likes immediately, which is kind of funny. I mean, and by immediately, I mean like within an hour or two, I had a few likes, which is kind of funny compared to, point being, YouTube. Like, I don't know why my posts would get more likes over there. Maybe it's a matter of, I mean, there's a couple things, right? So I have no idea about Instagram, honestly. Never used it before. But maybe there's a culture thing over there where it's just like, just like whatever the heck you got, you know? Whatever comes across your feed, rather, is what I meant to say. That could definitely be a thing. That they just automatically like everything for the heck of it. Bit weird, but I'll admit it is a little nice though. I will admit it's a little weird in my opinion, but it's also kind of nice to get the likes. I'll admit it is a little bit of dopamine. For the record, over on Instagram, Adamant Life was already taken, so it's Adamant Life YouTube YT, which evidently is also my YouTube one. I found out when I was checking the handle, and I could have swore I had Adamant Life as the handle before, but I double checked it when I was, making sure all my socials were accurate and up to date, and I found out that evidently I did not have that anymore. So, it is in fact Adamant YT, Adamant Life YT on YouTube as well. There we go. There's that guy, and that guy. Okay. That guy and that guy. Whoops. Did not click the button first. Okay. Alright, so those all roll. We can also toss a motion link in here. Actually, you know what? Let us... Do we have a rigid joint between the disc and... It doesn't look like it. So let's really quick while we're playing around with this stuff. Rigid group. Disc. Center shaft. As built. Center shaft and this bearing right here. And turn the center shaft off, turn that off, and let's grab the center of the bearing as a reference point. Okay, and then let's make sure that spins. I can't tell if it's spinning because I have no visual references. I'm guessing it's spinning, but the point being is we can create a motion link. Let's see, I think all these guys, can I do, I don't think I've tried doing more than... Okay, I can't. Okay. So these guys need to all be linked up. In case you could not tell, are these rolling in the same direction? I think they are. Yes. In case you could not tell, I'm not anticipating having this done by the end of the night, which is why I'm doing this right now. Instead of trying to put this off till later. That is the opposite. Reverse. That. Okay, so I need to come back here to this guy. Animate. Yes, and reverse those guys. Right. That's going this way. That's going this way. Yes. Looks right to me. And now double check these guys. Okay, cool. These guys are still good. And now, motion link this guy to... Where is my center one? I guess I gotta come up a level to see it. There it is. Motion link that guy to that guy. And I need a 10-to-1. Which one of these is moving quicker? So one of these is going to be 36. Okay, that's the opposite. So this is 360 and that is 36. Okay, cool. Oh no, it's not 10-to-1. That was incorrect. What was my notes? Notes was the bearing ratio 12.5. We'll just call it 12.7. It's a computer. I don't have to round for the computer. Oh, but I do need math. So, calculator. Actually, Fusion can do calculations for me. 360 times, or divided by 12.7. Times 1 degree. Okay. Animate. Alright, I'm gonna guess that's alright. I'm guessing that's alright. Alright, cool. Had our fun. This guy, let us actually, while I'm here, animate. Okay, good. The brown guy is not spinning. What are you guys? What are your positions? Oh, you guys are guys that I deleted. That's what you guys are. Okay. So the next thing is we need to get this connected to a cage. And we also need to worry about distance to the Dremel at this point. We also need the pulley. We also need to design the pulley. So one of these things, the cage is just tedious work. That'll take a little while. The pulley is going to take a little while, but that's fine just because it's somewhat interesting. Let me... Okay, let's see. I have... Okay, the hilarious thing here is that out of all my bands, the biggest one I have is not actually as big as I thought it was. So we need like 4 inches on the one side. And there is technically a correct angle of engagement. Okay, so that's hilarious. So I don't think I actually have a band big enough to do a 10-to-1. I have 2 bands that are pretty close to the same size. So maybe we can do a 2 5-to-1s like we were talking about earlier. So let's see relative to this shaft. I'll go ahead and start the pulley. I don't think I'm going to design the pulley. I think we're going to make this... So the reason I was talking about tedious and, you know, taking time and whatnot is because I'm considering when exactly we decide to call this for the night and leave the rest for part 2, because I'm thinking that it's only going to be a 2-parter. And the only reason I'm hesitating here is just because I've said that many times in the past and it's ended up going on a 3rd part. It's just, as always, I do not see how this is going to end up taking us more than 2 parts. I mean, all we got to do is design a pulley and then slap a cage on the thing, right? So I'm pretty sure actually, I have this model. I made this model. The 8mm miscellaneous. I actually should probably move all of these CNC things into their own module. So there's my Where's my pulley? Let's quick do a find. Find pulley. That is not the pulley I'm looking for. Alright, so evidently this is not in here. So where is this? I know we've used it before. We used it on the DIY CNC machine. No, don't. Stop it. No. Fusion. Clear. I don't want to search in miscellaneous. I want to search in the top level. That's why I exited out to the top level. Actually, you know what? Mini CNC. Components. There we go. So this one should be an 8mm, if I recall correctly. Nope, that's the 5mm. I do not recall correctly, evidently. I thought we used the 8mm in this design. We did not, so let me hop up here to what was the, oh, that's what it was. Nope, I can't remember where I put it. Alrighty, well, in that case, if I can't find it, let's see if Fusion's finally allowed to. No, I don't want to search miscellaneous. Fusion. Your UI is confusing. Let's see. Huh. Okay. So I don't have the 8mm one? The weird thing is that I could have swore I used the 8mm one. Actually, you know what? Let's hop back into the mini CNC really quick. Maybe what I did was I manually resized it in here. That's definitely a possibility. And if that's the case, if that's what I did, radius 2.5. Nope, that's a 2.5. That's not an 8mm. Over here, diameter 5mm. Okay. I have been proven incorrect, as it turns out. Alright. Fair enough, fair enough. Alright, in that case I do have to go grab the box. Ugh. Okay. Box grabbed, and the 8mm one. Lazy. Oh crap. Alright, 8mm one. 8mm one. It's still 12mm. Good. I'm glad we wasted all that time. It is the same OD. Alright. So, point being. This, in this case, would have to be... let's see... small pulley OD 12 millimeters. So this has to be small pulley OD times 10. We get our 10 to 1, and we compare that to, so that's practically the same size as the disc. Frankly, so long as it's not this not bigger than the disc, then it's not that big of a deal, because that means that that fits inside of the cage. So in theory, let's really just sketch out a cage, right? So the cage couldn't be any size, but the most I would kind of want to do the cage is just slightly larger than the disc. That's the biggest I'd want to do it. Actually, I take that back. So there is the idea of back to jigs. So I could make it a little bit larger to give ourselves more room to do jigs. But the point being, is at that point, we then, we can consider, at this point rather, having, well, see, yeah, I guess it still wants to be like over here. My only thing I was looking at is, in theory, this is an extrusion right here, okay? That's an extrusion right here. And then we attach the Dremel underneath. So in theory, this is the top bar and the bottom bar right here at this line right here. And then the vertical extrusion is right here. We attach the Dremel flex shaft to the vertical extrusion, and we run our pulley like this. Now again, like I said, oh, mystical fusion double line. As I mentioned before, there's technically an ideal angle of attack basically on these guys. Angle of engagement, that's what it is. Angle of attack. You attack and you engage the enemy. That's both things you do. So, and there's a correct angle of engagement on this, which would, in theory, dictate how far. You can see how that angle changes. How far this should be from that pulley. And I've got this right here. So small pulley OD. So there you go. So this guy, evidently, tangent. There we go. So you can see how the way this wraps around, how much of this big guy it wraps around, and how much of the little guy it wraps around changes as I move. So it's rough. It's rough because the size is so much different. I wonder if I Google this really quick. Maximum OD ratio between GT to 2DGT rather pulleys. 2GT pulleys. Let's see. What's this guy? Why is this? All right, whatever. I found a calculator that seems very, very not useful. It's a pulley ratio. It was just a pulley ratio. So all it was comparing one pulley to the other, and I couldn't find out. I can't figure out rather why it exists. Because it's literally just divide the one by the other. I'm not really seeing anything here, so let's see. Angle of engagement between pulleys. Engagement with sprockets. Actually, this is chain. So chain probably is similar to a... Boo. Yeah, too much talking. Wrap angle for big pulley calculator. That sounds useful. Let's see. Diameter of big pulley. So my diameter of my big pulley is 120 millimeters. Small pulley is 12. And the center distance is a thing I don't know. So let's see what happens here if I just leave that as is. So, what if I change this? I want to see if I can break the calculator. Yeah, I did break the calculator. Good. So distance here. What's my distance here? Let's say project out that. And then give myself, yeah, let's call it 6 millimeters of clearance, and then we can tangent that. So and I guess give myself 3 millimeters right here to that corner. There's that, and let's get this guy properly lined up on the corner. Centered rather. There we go, and this is 20 by 20. There we go. Tangent that. And tangent this guy over here. Whoops. Alright, so that is constrained now. So my distance is 103. So let's see if the calculator breaks on 103. Wrap angle for big pulley is saying 240. Yeah, I mean, I guess that very well may be 243-ish. So is that bad though? That's that's more of what I'm curious about. Correct wrap angle on pulley. 60? Is it really only supposed to be 60? Continue to site. Let's see. Allow 6 teeth in mesh and at least 60 degrees of... Oh, it says at least 60 degrees of belt wrap. So I definitely have more than 6 teeth. These 60 degrees. What's max though? I don't see a max on this page. Do. Let's see. It depends on the product of the wrap angle and coefficient, blah blah blah. Funny thing is that I'm almost curious whether or not this isn't fine as is. Oh, that's a quiz question. All right. Huh. So the only question would be this guy right here. I think. So that is 62 degrees. It's got to be more than 60, so that's technically more than 60. So I think this is fine over here. I think I'm not seeing something that says that you can't have a super large And one of those things, my Google Foo may just not be up to snuff. But it's looking like it doesn't necessarily matter that we're this far wrapped around on it, on this side, so long as this guy is over 60 degrees, which it is right now. And the other thing we can do, if in case, is we could adjust the angle on this side by bringing it in, by putting an idler on the outside here and pushing it inwards. So, point of this whole entire exercise is, I think our design is not inherently flawed yet. So, I think we will leave it there for just a moment. And when we come back, hopefully tomorrow, maybe not tomorrow. We'll see what happens. Tomorrow might be busy for me, but we'll go ahead and design this pulley and then design the mount for the Dremel flex shaft. And then, well, no, design the cage, then the mount for the Dremel flex. Yeah, there you go, shaft. So, those are the 3 things we need to get done, and then it should be complete at that point because it's a rather simple system. We're just driving a shaft. The only other consideration would be just maybe pinning the bottom of the shaft to make sure it doesn't slide down. Again, I'm not so sure that I'm concerned about the shaft riding up. It's definitely a possibility, but being as when we're using it, we're pushing down on it, I don't really see that happening. Now, if we are concerned about that, it's one of those things, then we just pin it on both sides of a bearing right to make sure that the shaft doesn't move up and down at all. And no big deal at that point. So the next question actually after that, and we may end up doing this, is this cross beam right here, the sport bearings, the plastic on the sport bearings. We might extend that out to the cage and have this whole entire thing, I don't know how much I like that. It would be an idea to have these catty corner to the cage and have them on the verticals, attach them to the verticals to give them support. That's an idea. Yeah, I could live with that one. Okay, so we'll look at that. So when we do the cage, we'll put it at an angle like this so that each of the corners, this extends out and bolts to each of the corners. And we may also pin underneath it just to give it support in the center. So it will be supported in the center, it will be supported on the ends by bolts, supported by in the center by a pin, and then supported on the ends by bolts. And that is the plan at this point. Again, looks pretty simple. The only thing that could possibly slow us down is just I've got to get the tooth profile. I've done this before. I know I've copied over the tooth profile for the 2 GT belts before. That's the idler pulley. Let's see if I can find it really quick. I may have done GT2 just because I always make that mistake. Yeah. So GT2 instead of, there we go. There's a tooth profile. So it would just be a matter of copying this tooth profile over to the pulley and taking the negative of it. So let's take a quick look at that sketch. One thing is, it says the sketch is not constrained, which I'm not sure what part of this is not constrained. And let's see, sketch. Oh, text command down here. Sketch, no autocomplete dot show unconstrained points. Nope. Okay. Capital S? Nope. No parentheses. Oh, there's a question mark. So let's see. It is definitely sketch. Oh, just show unconstrained. Gotcha. And it's capital S in show. Wait, no, you just literally told me. Oh, under constrained. Is that a couple C as well? No. I can read. I swear I can read. Capital S sketch dot show under constrained. Parentheses? No. I'm going to copy this. Get out of here. Paste. There it is. I don't know what I was misspelling, but that's okay. Aha. That is what we call a fusion double line. Deleted. Connect. You were supposed to be connected to there. All right. Finish. All right, cool. No longer under constrained. And we can mark that as read only again. And that will be it. So again, guys, to reiterate, things will be out as they come out at this point. I'm trying to get everything through the pipeline. Again, I am starting to do videos again because one of those things, videos are what people are used to. My videos definitely do better than my streams, unfortunately, for the time being. We'll see whether or not that changes in the future. Again, I think streaming is an interesting avenue for maker content, and I think it's useful. I think it's a useful tool to have, a useful ecosystem to have implemented. So that's why I'm going to continue with streaming, just probably not as much, because at the moment, people aren't really looking for that. And one of these things, if I can get more people watching videos, I can get more people watching streams, in theory. So we'll get more people watching videos because, again, videos do pretty well that I put up. Otherwise, as I stated, I do have Instagrammer now. So that would be Adamant Life YT. In other words, Adamant Life YouTube, but I'm not going to type all that out. So it's just YT. So feel free to follow me over there. I do have in progress pictures from projects, as well as any little things that I do on the side. For example, today I posted a picture of a quick vertical holder design based off of the phone holder that we made for the turntable for the Prusa Printables flash design contest that we had entered forever ago. So that was a nice little fun redesign, I guess I'll call it. That is up on Printables as well, for the record. So feel free to check out my Printables and see if there's anything on there that you forgot that I made, or if you want to just steal the sketches. One of those things, again, I'm going to put a little bit more effort into doing all the social stuff, and that would include Printables. So let's see. Anything else to say? I don't think so. So, as always, guys, thank you guys for watching, and I hope you have a great, wonderful day, afternoon, or evening, wherever you're at in the world, and I will catch you next time.